Previously in this learning path, we have covered the fact that functions in JavaScript are considered first-class members. This has various effects on how exactly we write code with regards to functions. And in this video, we will take a look at some of the aspects which make functions first-class members. For one, we will define a function to return a function, and we will also assign that return function to a variable in order to invoke it later on. As with the other demos in this learning path, I have an HTML file which points to a JavaScript in this case. And the focus of this demo is going to be on the JavaScript source. So we head over to that straight away, where we start off by enabling strict mode. And then following that, we will define a function. The function itself is rather trivial. It accepts two arguments and it returns the sum of those two values. What needs to be noted is how exactly we define this function. So we initialize a variable called addition to represent this function, and its value is what is known as a function expression. Here we use the function keyword followed by its parameter specified in parentheses, and then we have the function body within curly braces. This is the equivalent of a function declaration, which is more common in other programming languages, where we have the function keyword followed by the name of the function and looks something like this. Whichever syntax you use though, the function behaves in the same manner. Alright, with one of our functions defined, let us now define another one called multiplication, which returns the product of the two arguments supplied, and then another one called subtraction, which returns the difference, and then a division function, which returns the dividend of the supplied arguments. So in each of these cases, we are able to assign functions to variables. Now, one more effect of functions being first-class objects in JavaScript is that we can supply them as arguments to other functions. So let us now define a function called calculation, which takes in three arguments. The first of these represent numbers on which a calculation needs to be applied, and the calculation function itself is the third argument. So in our calculation function, the calculation type will be applied to the arguments a and b. So note here that this calculation function is defined using a function declaration rather than a function expression. We can now put this calculation function to use by invoking it in order to perform an addition of 10 and 30. The result will be stored in the variable output. So the addition variable here represents a function, and we will now test out whether this can be passed as an argument to the calculation function. And the output which is printed to the console should be 40. So to perform this test, we open up the HTML in the browser, and once it has been loaded, we will bring up the console. And clearly we can see that the addition output has been calculated correctly. We will now invoke the calculate method once more, but this time we pass along our division function as the argument. And this time, the output has once again been correctly calculated as 0.33. Heading back to the code now, it should be clear that you can invoke this calculation function by passing along other functions as arguments. We will now explore one more aspect of functions being first-class members of JavaScript, and this is where we get a function to return a function, and we will invoke that returned function a little later on. We will explore that, however, in the next video. We continue with our exploration of functions being first-class members in JavaScript, and we will now see how we can get a function to return another function. So before we get to that, let us define a few objects which we need to work with. One of these is called FX rates, and this contains the foreign exchange rates for two different currencies, Indian rupees and euros, with respect to US dollars. We will imagine that we are part of an e-commerce platform which sells products globally, and that it has customers in India as well as Europe. but its accounting is done in terms of US dollars. So now that we have the exchange rates for these two regions, we will now define one more object which contains the discounts which are currently applicable for those regions. In case of India, there is a 10% discount, and in Europe, there is a 20% discount in effect. So realistically, you may imagine that especially the FX rates object is something which is constantly changing, which is why we may want any function which makes use of the FX rates object to defer execution until it is actually required. Alright, so our fictitious e-commerce company now has these exchange rates stored, and there are also some discounts which are applicable for two different regions. Which now brings us to the shopping cart of one of the customers of this company. Let's just say this is a customer from India. So we have this Indian cart, which has an ID of 1, and the total value of the purchased item is 81,000 rupees, which is represented by the total and currency fields of this object. Now there is also a European customer with an ID of 2, and this person has made a purchase of 772 euros worth of goods. Now let us assume that the discounts are something which don't change that frequently, which is why as soon as the person has hit the checkout button on this e-commerce platform, you wish to apply their discounts right away. However, ultimately your goal is to store the purchased value in terms of US dollars, which is why you need to apply the FX rates for each of these cards. The foreign exchange rates, though, may change literally every second, so you may want to apply that at the very last moment. So how exactly could you do that? Well, one way is to have a getTotalPrice function which accepts a cart as an input, and it'll apply the discount on the cart depending on the region, and also apply an exchange rate, and then return the total value of the goods purchased in terms of US dollars. It does this, however, in effectively two different steps. Let's just say the user hits the checkout button, then we can apply the discount to whatever is there in their cart. So here we calculate the final total for the cart as the cart total times 1 minus the discount rate. So this final total is calculated and stored within the cart object, but this is still in terms of the local currency and not in US dollars. To calculate the US dollar value of the purchased items, we define one more function inside the getTotalPrice function. So this is called total USD price, and it references the cart.finalTotal attribute, which has been calculated just prior to this, and it applies the foreign exchange rates as defined within the FX rates object to this final total value. So this is the USD price of the items in the cart, and this is what this inner function returns. And that inner function itself is what is returned by the getTotalPrice function. So what exactly does getTotalPrice function do? Well, it accepts a cart as an input argument, and then it calculates cart.finalTotal as specified within the body. After that, it defines but does not execute the total USD price function, and then returns this function to the caller. What this means is that the final total is calculated as soon as getTotalPrice function is invoked, which means that the discount will be applied at the time. However, the total USD price function has not been executed yet, and it is up to the caller when they choose to run it. That is when the FX rates object will be looked at, and the prevailing exchange rate will be applied. So now let us go ahead and invoke the getTotalPrice function on the Indian cart. When we do that, the discount which is applicable for payments in Indian rupees will be applied, but the exchange rate is not calculated. In fact, the function which calculates the exchange rate will be returned, and we capture this in the variable InCartTotalUSD. And as soon as we do that, let us first print out the type of object which InCartTotalUSD is. So we invoke the type of operator in order to do this, and we can now head over to the browser to see what exactly that variable represents. And we get the answer that it is a function. So function is a type in the JavaScript language, which again alludes to its treatment as a first-class member. So once a user has checked out the items in the cart, we can apply the discounts. And when they finally hit the purchase button, we can calculate the total amount of the purchase in USD by invoking the return function. So we can now go ahead and invoke in-cart total USD. And to check out its output, we head over to the browser. And this has calculated a total USD value of 1012.5, which is the equivalent of 81,000 rupees, given the exchange rates which we had set. Heading back to the source now, we can invoke the getTotalPrice function once more, but this time for the European cart. And then we calculate the price in USD for that cart by invoking the return method. A question at this point is, when we invoke the return function, will we be able to reference the same cart object which was passed as an argument to the getTotalPrice function? That is, will the reference to cart.finalTotal inside the definition of total USD price be pointing to the same cart.finalTotal defined just outside it? Well, we can head over to the browser in order to confirm this. So when we hit refresh, the value for the EU cart has been calculated as a little over 686 US dollars. You can do the math by applying the discounts and also doing the price conversion on your own, and you will see that this is the correct value. So going back to our function definition, it is clear that cart.finalTotal inside total USD price is able to reference the same cart.finalTotal which was calculated earlier on. The reason this is possible is because the inner function, which is the total USD price, is in fact packaged with the fields defined just outside its scope. We will discuss that in more detail when we cover closures later on in this learning path. We now explore one aspect of programming languages in the context of JavaScript. This involves the passing of arguments into functions by value and by reference. So once again, we have an HTML and a JavaScript file for this demo. And let us begin coding up the JavaScript. Once strict mode has been enabled, let us define a function which is called pass by value and reference. From within this function, we will make a call to another function, and to that we will pass along some variables and see whether it gets passed by value or by reference. In case you're unfamiliar with what exactly those terms mean, this demo should make things a little clearer, so just follow along. Within our function, we define two variables. The first of these is called name, and its value is a simple string. The second variable, person, has a value which is an object. So within this object, we have two different fields, name and city. First, let us print out each of these variables to the console and see what they look like. But note here that we have not explicitly invoked this pass by value and reference function. So when we pull up the HTML in a browser, that page loads successfully. But when we bring up the console, neither of those console.log messages have been invoked. This is because our function has not been invoked. So we go ahead and make that function call in the source code. And this time when we refresh the page, both the name as well as the person variables have their values printed out. So name is just a simple string, whereas person is of course an object containing the city and the name. Alright, this is simple enough, where we have a primitive type, which is the name variable, and then an object type, which is the person variable. We head back to our source code now, and then define another function called modifyData, which accepts a primitive type and an object type as an argument, and then makes changes to each of them. So whatever primitive type is passed in, it will set it a value of the string Victor. And to the object which is passed along, it updates its name field to Olivia. With those changes made, each of those input arguments will be printed out to the console. Now it's time for us to invoke this modify data function, and we do that from within our pass by value and reference function. So we pass along both name as well as the person variables to this. So when we do that, the question becomes, what are the values of the variables which are printed out from within the modified data function? Well, to test it out, we just head over to the browser and refresh the page, which means that both of the functions are invoked, and it's clear from the output that the primitive type which was passed in to the modified data function has had its value changed to Victor. Also, the object which was passed in has had its name field updated from Myra to Olivia. So, the modified data function has been able to accept both a primitive type as well as an object type as an argument and has successfully modified both of them. The question now is whether these modifications have been reflected in the calling function. To test that out, we head back once more to our source code, and then following the call to modify data within the pass by value and reference function, we add two more console.log messages, where we print out the values of the name and person variables. So the question now is whether modify data has changed the variables only locally within its own scope, in which case the value of name will still be Tyson, and the name attribute in the person object will still be Myra. In such a case, we say that these variables were passed by value to the function. On the other hand, if these newly added console.log messages show Victor and the name field as Olivia for person, it means that when we passed along those variables to modify data, we in fact passed along their references. So, to test it out, we head over to the browser and hit refresh. And what we see is that the name variable is exactly the same as it was before. So this is still Tyson even after the call to modify data. However, in the case of the person object, the name field has been updated to Olivia. What this means is that primitive types such as strings are in fact passed by value to functions, whereas object data are passed by reference. This behavior in JavaScript is similar to that in other programming languages, where primitive types are passed by value and object data by reference. And this is something you need to be mindful of when writing your JavaScript code. If you're coming into JavaScript from another programming languages like Java or Python, for example, you will have seen by now that functions in JavaScript are quite a different animal. In this demo, we continue exploring one of the other unusual features of functions in JavaScript, where we can make use of the new keyword in order to create a function out of a string. So once again, we have an HTML and JavaScript, and let us switch over to the JavaScript first and enable strict mode. Now, before we begin any coding, let us consider why exactly we might want to create a function out of a string. One of these cases is when we wish to get the function body from the user. So to enable that, let us now create a new variable called funcBody, and the body of the function will be something which is obtained from the user by invoking the prompt method. This method is used to obtain input from a user in the form of a string, and it's no different in this particular case, where the function body will be stored as a string in the funcBody variable. So how exactly can we create a new function out of the string? Well, we make use of the new keyword followed by function with an uppercase F, and then within the body, there are a few details we pass along. We can specify the arguments to the function, and at the very end, we pass along the function body in the form of a string. So what we have here is a function which takes in two arguments, a verbal score and a math score, and let's just say that the function body operates on each of these arguments in order to return a weighted score. It is not the actual calculation of the weighted score which is returned, however, but instead it will be a reference to the function. So weighted score is in fact a function which can be invoked. And to confirm that, we will invoke weighted score and we will pass along the arguments of 78 and 91, which are the verbal and math scores. So what we have so far include the function signature, where we have a function name of weighted score, and that it accepts two arguments, a verbal score and a math score. What exactly happens within the body of the function is something the user will need to define. So let us get down to that. Saving down this JS file, we bring up the HTML in the browser, and the moment we load up this page, the prompt message shows up, asking us to enter the body of a function. Let us keep this one simple. We simply return a weighted score calculated as 2 times the verbal score plus the math score divided by 3. So the weighted score has twice the weight of the math score in this case. Now just to summarize where we are at this point, we are just applying the function body, which clearly expects that verbal score and math score are variables which it can reference. So once we hit OK, the function body should be loaded into the JavaScript. And you'll recall that there is also an invocation of the function within our code. To see exactly what that returns, we will need to pull up the console. And we can see here that the weighted score for a verbal score of 78 and a math score of 91 has been correctly calculated as 82.33. So we have successfully created a new function out of a string which was passed in as user input. We can continue performing a test by reloading the page. Once again, the prompt message comes up, and we can conduct an experiment to see what happens if we supply a blank body. Well, the function invocation returns undefined, since clearly there was no function defined in the first place. Continuing with our experiments, we can refresh once more, and this time I'm going to hit cancel. And once again, a value of undefined has been returned by the function invocation. Alright, let me reload the page, and I'll go back to specifying a valid value for a function body. And as you might expect, a valid value has been calculated for the weighted score. Going back to our source, we will now invoke the function for a second time, passing along two different arguments for the verbal and math score. We can reload the page again, and I'm going to specify the same function body for the third time. However, feel free to change the definition for your function. Whatever you do, you should see a valid value for the score printed out. So we now know how we can create a new function out of a string. In the example we have covered so far, that string was something which was supplied by a user. However, it can really be any form of string. Here, we create a new function out of a string literal. So this particular function called greet will simply print out to the console the message, "Welcome to Skillsoft." So following that, we can invoke the greet function to see that this message is indeed printed out. And now reloading the page, I will once again specify the same function body for the weighted score function. And the output in the console confirms that it's not just the weighted score function, but also the greet function, which has been successfully invoked. So being able to create a function out of a string is clearly not a common use case. But in the rare occasion that you do require such a feature, you now know that JavaScript has you covered. We have already seen that in JavaScript, functions can be passed into other functions as arguments. And we will now explore a special case of that known as the function callback. This is where you invoke one function by passing a second function as an argument, with the expectation that the second function will be invoked after the operations performed within the first function. We will see exactly how this works in this demo. So we head straight over now to the JavaScript. And what we will do is to first define an array of objects. And this is something we have taken a look at earlier on in this learning path. So consider that each of these objects represents items which are purchased in a grocery store. And first, let us calculate the total price of all of the purchased items. And we do this in this getTotalCost function. So this accepts an array of objects as an argument, and then it calculates the total price of the items by applying the reduce method, and then returns this total. We will invoke this function using our items array now, and the total cost of our purchased item will be stored in this variable total cost. Before we proceed, let us print out this total cost to the console. So what we're doing here is aggregating the price for each of the items using the reduce method. So we will test this out by bringing up the HTML in a browser, and from the console, the total cost is correctly calculated as 100. Alright, so now that we have calculated the total cost, let's just say we wish to apply one more operation. Specifically, we want to calculate what the total cost is after taxes have been applied. To do that, we define an apply taxes function. So this takes in the total cost and returns 1.05 times that total cost. Effectively, it applies a tax rate of 5% on the total purchase of items. Now, it is important that the total cost is calculated before the taxes are applied. So there is a clear sequence of execution here, where we first calculate the total cost by invoking getTotalCost, and then from the return value, we invoke apply taxes, and this will return the total value after taxes. To test this out, we head over to the browser, and the total value of the purchase after taxes is 105. So from our source, it is clear that we need to invoke getTotalCost first, and once it is done executing, we can invoke apply taxes. Now, one way to ensure the sequence of execution in JavaScript is to implement a callback. Here, you can invoke a particular function, but one of the arguments which you supply is the function which needs to be executed right after that. And this one is known as the callback function. To see exactly how this works, I am going to comment out the definition of getTotalCost because we will be redefining it to include a callback. While doing this, we can comment out the invocation of this getTotalCost method along with the console.log message. So at this point, we only have the definition of our array of objects along with the apply taxes function. So we can now proceed now and then redefine the getTotalCost function, except this time it accepts two arguments: the list of items just as it did before, but also a callback function. Within the function body, we calculate the total cost just as we did before by invoking the reduce method on the items. But following that, we invoke the callback function, to which we pass along the argument of total cost. So what is returned by getTotalCost is in fact the value which is returned by the callback function, which is passed to it as argument. With this definition of getTotalCost, however, we can see that the total cost is always calculated before the callback can be invoked. And this is a very commonly used practice in order to ensure that functions are executed in a certain sequence in JavaScript. So now, let us invoke getTotalCost, where we pass along our items array along with the apply taxes function. So this will calculate the total cost and invoke apply taxes, and the value returned by apply taxes will be captured in the variable total after taxes, which we proceed to print to the console. So what happens when we perform this function invocation with the callback? Well, what we have in fact is an uncaught reference error, and heading back to the code, you'll see that this is because we have not declared the variable total cost within our redefined getTotalCost function. since we are running in strict mode, we will need to include this declaration. So now that we have included the var keyword, we can save down this file and then reload the page in the browser. And this function invocation with the callback has correctly calculated the total after taxes as 105. So callbacks are a very convenient and in fact a very commonly used way to ensure that functions are executed in a certain sequence in JavaScript. In fact, you may have callback functions which in turn accept callbacks as arguments, and it is possible to end up with code where you have a series of nested callbacks. As you can imagine, this could get rather confusing and is referred to as callback hell in the world of JavaScript. As with many features in JavaScript though, callbacks are very useful, but it needs to be used with caution. Earlier on in this learning path, we saw that how we can define a function which references the fields of an object using the this keyword. We also saw that we can invoke the call function in order to link a specific object to the function call. In this video, we will revisit the call method, but also take a look at the apply and bind methods in order to similarly link function calls to a specific object. So let us head over now to the JavaScript, and we begin by defining a couple of objects for us to work with. The first of these is called first scorecard, and it represents the math and verbal scores of a student named Clara. There is a second student called Steve who has his own scorecard here. And now let us go ahead and define a function called print weighted score, which can operate on an object which contains the fields name, math, and verbal. So it should be able to operate on both of our scorecard objects. The arguments to this function include a weight for the math score and also a weight for the verbal score. And within the function body, you can see exactly how this weighted score is calculated. We reference this.math and this.verbal. In the next line, we reference this.name when we print out a student's weighted score to the console. So, given that this function is defined outside of any object, how exactly can we link this function to a specific object so that the this keyword is in fact a reference to that object? Well, this is something we have covered a little earlier. So this time, we call print weighted score dot call, and the arguments to this include the object to which the print weighted score function should bind to, followed by the arguments to the function itself. So in this invocation of print weighted score, this will reference first scorecard. The math weight in this case is 2 and the verbal weight is 1. We can confirm that it behaves exactly as expected by pulling up the HTML in a browser. And when we navigate over to the console, we can see that the weighted score has been calculated as 77.33. Alright, so now that we have the weighted score for Clara, let us calculate the same weighted score for Steve. But in this case, we apply a different set of weights for the math and verbal scores, where each of them has a weight of 1. So heading over to the browser, the weighted score for Steve is 81. Alright, so now we know that we can invoke the call method of a function in JavaScript in order to link that function call to a specific object. In particular, we determine what the this keyword will reference within the function body. We now perform a similar operation by invoking a function's apply method. So this works similarly to call, where it links a specific object to the function call, except in this case, we pass along the arguments to the function in the form of an array. So in our first invocation, we link print weighted score to first scorecard, but the weights of 2 and 1 are passed along as elements of an array. And similarly, in the second invocation, the function is linked to second scorecard. And when we head over to the browser and refresh, the weighted scores for Clara and Steve are calculated exactly the same as they were previously. So call and apply work in similar ways, except that they have a slightly different syntax. Which takes us now to a related but slightly different function called bind. So in the first invocation here, we call print weighted score.bind and passes the argument of first scorecard. But in this case, the function is not invoked, but it is simply bound to the first scorecard object. What is returned by this call to bind is a function itself, and this is captured in the variable first score. Following that, we have a similar variable second score, which is the print weighted score method, but bound to the second scorecard. So the bind method is something which is used to bind a function call to an object, but it does not invoke that function itself. So now that we have two different variables which represent functions bound to different objects, we can go ahead and invoke them. First, we invoke first score with the arguments 2 and 1, and then second score with the arguments of 1 and 1. And from the browser, we can see that once again, the weighted scores have been calculated in exactly the same manner as before. So the bind method does work similarly when compared to call and apply, with the difference being that the function is simply bound to an object and that it needs to be explicitly invoked later on. Alright, we will now take a look at some of the limitations of call, apply, and bind. But before we get to that, let us comment out all of these console.log messages and these function invocations. And now, we define a function which makes use of the arrow syntax. You'll observe that weighted score arrow performs a similar operation as the print weighted score function. It has the same arguments, calculates the weighted score in the same manner, and then prints out the student name and the weighted score. However, in the last line, we will also print out the value of this within the function just to illustrate what exactly this has been bound to. Following that, let us invoke our new weighted score function by using the call method to bind it to first scorecard. And heading over to the console, we observe that this returns a nan value for the weighted score. And importantly, we can see that this, even within the function, references the window object. So why exactly is this pointing to the window object and not the first scorecard object in this case? The reason for this is a property of arrow functions, where they inherit their scope from their parent, where they are invoked from, and do not have their own scope. So from the source, since we are invoking this weighted score arrow function from within the main scope, it is that same scope, which is the window object, which is referred to by this. The same is also true if we invoke the arrow function using apply. So when we try to link it to first scorecard, once again, we get a nan value for the weighted score, and the value of this from within the function is window. We will in fact get the same result if we were to apply the bind method on weighted score arrow. So heading over to the console, we see that once again, a nan value is calculated for weighted score, and this points to the window object. So while the arrow syntax in JavaScript is great for compact function definitions, you need to be careful when applying it to functions which need to be bound to specific objects. In this lab-only course, we covered some of the advanced operations with regards to functions in JavaScript. We started off by examining the concept of functions as first-class members of JavaScript, by first assigning functions to variables, then coding functions to have nested functions as return values, and then by passing functions as arguments to other functions. We also looked at how data is passed by value or by reference to JavaScript functions. We then went on to implement callbacks in order to execute functions in a sequence. And finally, we invoked a function's call, apply, and bind methods in order to link a function call to a specific object. At this point, you will be quite the expert on functions and will be in a great position to move on to more advanced topics which are related to functions, such as closures and prototypes in JavaScript.